Have you ever added more expensive hardware just because your database system cannot handle complex queries with lots of table joins? If that performance struggle sounds familiar, this video is for you. While relational databases excel at so many things, they may struggle when dealing with queries involving high volumes and a lot of joins. Graph databases, on the other hand, can perform much faster and more cost efficiently when dealing with highly connected data. Also, did you know you can use natural language to query a graph database using Amazon Bedrock? Hi, I'm Carlos Contreras, and in this three-part video series, you're going to learn about graph databases and how to load and query data in Amazon Neptune. All this by deploying an infrastructure as code project using Amazon CDK, which includes a graph data generator. Picture yourself working at a company that offers scooter rentals to customers. This will be our use case, but this also works for any type of vehicles, IoT devices, or even smart buildings. One of our important duties in this company is to manage and monitor these scooters in real time. This helps us in detecting damaged scooters and show us their locations. For example, they can be in our warehouses, parking stations, in transit, or even dumped in a canal. We also need to analyze many types of incidents and claims submitted by drivers to ensure there is no fraudulent activity. Before we carry on, let's use our scooter scenario to understand what a graph database is. While we could build this data structure in a relational database, think about the query behind this request. In the last week, how many claims did we have due faulty batteries when the weather temperature was less than 10 degrees? In this query, we need to involve multiple elements, such as weather information, trips, scooters, parts, incidents, faults, and claims. In a relational database, this might mean joining 6 tables for this simple question. Imagine having millions of trips per month or per day. Joining 6 tables with high volumes may lead to bad performance in a relational database or a very expensive architecture. This is where graph databases shine with highly connected datasets just like this one. In our graph, we can simply do something like this and run this query efficiently. But before that, let's make sure we have the following requirements: AWS CLI, Python, Docker running locally, Node.js, Amazon CDK, and VS Code with the Amazon Code Whisperer plugin. All the instructions for this are in the blog post, and you can find the link in the description. Let's begin by cloning our Github repository so we can build our end-to-end architecture. After installing the requirements, let's now clone our CDK project. Enter the following instruction to clone our GitHub repo. And now let's confirm that we have it and go into the directory. Let's make sure that we have all the correct file and directory structure. The next step is to open Visual Studio Code from this same directory. And now, open a new terminal and create our virtual environment. Now please enter the following instruction to load the virtual environment we just created. Now we need to install the project requirements. So please enter the following command to install this. And that's done. Nice work! We now have our CDK project locally with all the dependencies we are going to require for this lab. But before we jump into the Amazon CDK code, let me ask you a question. Have you ever had an incident where the application or system was failing due to an incorrect manual configuration? Something like a missing database parameter or an incorrect firewall rule. When you need to deploy and configure, let's say a database for your scientists at work, for your databases, you need to follow an internal document, such as a traditional SOP document, to ensure that all those specific databases follow the same standards. All these steps can be time-consuming, repetitive, and prone to errors, but they can be fully automated by using infrastructure as code. This is where Amazon CDK comes into the picture. Let's now have a look at all the assets our CDK stack will create, such as IAM roles and policies, Neptune databases and notebook, and an API gateway, and more. Remember that prerequisites, such as installing your AWS CLI and having your Docker running. Let's now open our application file and let's have a look. So from here, optionally, we can change multiple aspects, like the default AWS account or region where we want to deploy our CDK project. Now, If you want to change the region, just have a look to the documentation to confirm the AWS services we are using, like Amazon Bedrock, are supported there. Remember that if you have any questions, just leave a comment below. We can also change the business environment here. Let's say that you want to build this project for multiple environments. For example, for your sandbox or development accounts. And once you test everything and confirm it works, what you can do is you can redeploy the same CDK stacks, but for pre-production. This could also be useful to deploy on the same account and region the same stacks, but using different parameters for testing. So for that, you can have multiple business environments defined here in our CDK JSON file. As you can see here, we have defined only one, but you can add as many as you want. For example, in this case, we're going to create a new VPC as we're not including a VPC ID. But if you want to deploy the Neptune database in your existing VPC, then you can add your own VPC ID here, and the CDK stack will do the rest. You can now go to stack VPC Neptune to confirm relevant details. For example, confirm the network ranges we are using, and that won't interfere with your network. The next parameter is the prefix. We can use this code and you can change it to something more related to your company. You can also change the number of vehicles here, in this case from 1,000 scooters to a different number. You can also change the number of parts per scooter. This represents tires, batteries connected to the scooters. The last parameter is for our API gateway. Imagine you have an application and a local client, and you want to connect this to our database, Neptune. In that case, you can add their IP addresses here, and that way they will be able to access the database through our API gateway. Just bear in mind that all these parameters can also be stored somewhere else, for example, in the Systems Manager parameter store, which could be a good idea. The stack called SSM can help you with this already. It's already defined there. So now go back to your application file, and let's have a look to all the stacks that we have defined here. As you can see, we have different stacks in a very modular way. We have an Amazon S3 stack here that will create the bucket for our graph data. We also have our Lambda stack for our graph data generation, which will leave the graph data in the bucket we created in the previous S3 stack. It's like building Lego blocks, but using CDK stack. Let me just scroll down. You can define any hard dependencies in this section right here. For example, this Lambda stack is going to have hard dependency on the S3 bucket we are creating. And the same case for the VPC and the Neptune database. By the way, you can deploy these stacks individually, but in our case, we're going to have the deployment in one go. Finally, we're going to tag our resources to follow best practices. Tags are very useful to categorize resources by departments, for example, and monitor your cost based on those specific tag groups. You can even filter at the stack level, for example, to track the cost from your Neptune database or for the storage used in your S3 bucket. So let's now open a new terminal. And let's load our environment. And make sure that we have Docker running. Remember that all the details are in the documentation. Now let's confirm our CLI is working, and that is pointing to the correct environment. In this case, I don't have any EC2 instances, but the command has worked, and I have confirmed in my credentials file that we are pointing to the correct environment. Okay, let's just make sure that we have, and we can list all the stacks in our CDK application. Okay, that worked, perfect. Let's now bootstrap our AWS account. Okay, so that's done. Just remember that bootstrapping is the process of preparing an environment for deployment. It's a one-time action, by the way, so you must perform this for every environment that you deploy resources into. Let's make sure that we can synthesize all the CDK stacks now. And this command will try to generate the CloudFormation templates for all the resources we are building in our CDK stacks. In there, if there are any syntax or logic errors, this will let us know as well. So now let's enter the following command to deploy our CDK stack. This will also create our Docker image and the Lambda deployment package as well. Enter yes here to confirm the security changes. This process should take around 15 to 20 minutes and it creates the entire infrastructure for us. That's all for part 1. Thanks for watching. If you have any questions, drop us a comment below and we'll get it answered. In the next video, you'll learn about how to load and query the graph. We'll also show you how to use generative AI tools like Amazon Q and Amazon Code Whisperer to build graph queries easily. If you are enjoying this series so far, please give it a like and consider subscribing to our AWS Developers channel. I'll see you in part 2.